Hello, welcome to stpete.net meetup. Tonight's program is software engineering in an agile environment. We've got David Corbin here. Going to be doing our lovely talk on that. I would like to thank our sponsors. First of all, Iron Yard provides this great space for us. Tech Systems has brought some food in the back, so if you haven't already, go ahead and grab some chicken and whatever else is back there. We've got some giveaways. We've got Pluralsight, JetBrains, and Wiley tonight, some Rocks books. So we'll be raffling that off at the end of the presentation. So with that, David?
Okay, so no surprise, tonight's talk is software engineering in an agile environment. A little bit about myself. I'm a long-term developer. I started cranking code, it was still the 1970s, and I still write a lot of code today. Some people say I'm OCD, and I say obsessive compulsive is not a disorder, it's a benefit. I also happen to be a Microsoft MVP and one of the Microsoft ALM Rangers. So I'm pretty tight in with the .NET community. It accounts for probably 85 to 90% of the software I write. So in order to talk about software engineering in an agile environment, we have to figure out what is software engineering. Okay? There's a difference between software engineering and just application development. So one place to start is with dictionary definitions. A branch of computer science that deals with the design, implementation, and maintenance of complex computer programs. Doesn't really tell us much. But if we dig into computer science, a branch of science that deals with the theory of computation or the design of computers. There's a gotcha here. Most of us are not concerned about the theory of operation of the computers. When was the last time you thought about processor pipelines, L1, L2 cache? It's not something your typical application developer worries about. We're also not developing hardware. So those dictionary definitions have a little bit of trouble. So if we back up a little bit and say, let's see, instead of the definitions of the words, let's look at some things that are about the principles. Engineers are improving the world all the time. Hopefully we're doing that. They develop creative, practical solutions and work with teams of smart, inspiring people to design and build technologies that make a difference. That's sounding more like us, hopefully. And they apply scientific principles to design and develop structures. So it's not the science itself, but it's the principles behind the science. And I'm not going to bother reading the rest of it. You want to read it? It's from Encyclopedia Britannica. Remember those books on the shelf? And yes, I got it online. I don't have it. So now we sort of got a guide as to what software engineering is. It's going to be some science behind writing software, rather than just trying to crank out an app that happens to work. So what's an agile environment? Now, there's so many things. There's actually two distinct meanings of the word agile. And sometimes I find this very frustrating. The first is the Agile Manifesto. Okay? Agile Manifesto, 4 value comparisons, 12 principles, and it was published in 2001. Has anyone here not heard of the Agile Manifesto? So you've at least all heard of it, or too shy to raise your hands. To me, following those 12 principles to achieve balance in those 4 value comparisons is the more important meaning of Agile. For better or worse, it's now applied to any number of iterative processes. Okay? So things you'll see down here in this meaning, that thing, we have backlogs, we have sprints and iterations, we have story points or effort, we have user stories or PBIs if you're doing Scrum, bugs, defects if you're using Scrum, the differences in TFS terminology. These have very little to do with those. The bottom set is practical guidance that people have come up with that they believe is supposed to get you in good standing with the first set. But there's often a big disconnect. So what I'm going to do is I'm going to take and make a definition just for this session. I'm not arguing that this should be a universal definition, but we have to sort of resolve those two completely distinct definitions. Any highly iterative approach, 2 to 6 weeks, that utilizes, utilizes a prioritized list of items to be delivered as working software at the end of the iteration, which is focused on following the 12 principles and achieving the 4 values. So I've sort of merged the two together. So a good implementation of Scrum would fall into this, general Agile would fall into this. Long, heavyweight processes that were typically called waterfall, not so much. Are we good with that definition? Anyone want to disagree with it? Okay, good. So, how do we bring the software engineering that we talked about first with that agile environment? Well, most of the things you hear, I mean, if you go to any of the agile meetups, any of the Scrum guides, I happen to go to 3 lean coffees a month, all on Fridays, 2 in Tampa, 1 in St. Pete here. They're great, but they're always about work planning. How do you manage the backlog? How do you do story pointing? How do you do sprinting? And then they say, yeah, you break it up into tasks. Not so much information on how to break things up into tasks, and nothing about how to execute the tasks. There's little information available about how to execute within the iteration following good engineering principles. And our goal tonight is to change that lack of information. There are anti-patterns, things we do not want to do. Agile is not ad hoc. I've ran into some people who, especially managers, oh, Agile means we can do whatever we want, whenever we want. Not really. We don't want to waste valuable resources, and valuable resources, being selfish, means our time as developers, or other resources too, right? And we don't want to be penny wise and pound foolish. We want to try to save a nickel here, save a dime here, and end up losing it all down the road. So this gets us just to our starting point. What I did was I went through the 12 principles of the manifesto and looked for certain key things that are engineering related. What secrets are there in the manifesto about engineering? The best architectures, requirements, and designs emerge from self-organizing teams. How many people have heard at least once, oh, we're doing Agile, we don't do architecture? Has anyone heard? I'm seeing some nods. You hear that? Oh, we don't gather requirements, we're doing Agile. Oh, we don't have designs, we're doing Agile. That's not what it says here. The difference between classic so-called big requirements up front, you'll see it abbreviated as BRUF, is that these elements emerge. And they emerge from self-organizing teams. I have a whole nother session on self-organizing teams, so that's why I didn't highlight that one here. But these 3 things, architecture, requirements, and designs, are part of Agile. It's just instead of trying to pin them down all up front before doing anything, they emerge from the work that we do. Number 9, continuous attention to technical excellence and good design. There's that design word again. And not just design, but good design. Not mediocre technology, not that, well, it barely works, but we're not sure how stable it is, but technical excellence. I love throwing these back sometimes at certain people who think they're in the product owner role. So what can we find from the manifesto about cadence, the rate at which we're going to work? Working software is the primary measure of progress. So we want to make sure we don't have long periods of time where we have broken software. We want working software. Ideally, we want working software all the time. We don't ever want broken software. We welcome changing requirements. This doesn't mean wrong requirements. This doesn't mean lacking requirements. In order for something to change, it must have a state that becomes a different state. And I go really strongly with a lot of teams when I'm in as a mentor or coach on the difference between the two. And we'll talk about that in a little more detail later. Early and continuous delivery of valuable software is how we achieve our highest priority of satisfying the customer. Early and continuous. How many teams here write code? How many teams here, by the way, work in a so-called Agile environment? You work in iterations. Okay. You basically just go continuous long death marches?
No, I'm an independent.
Okay.
I don't run teams.
I'm 99% independent developer. I run a corporation, but it's me. My wife runs the business side of it. I set things up. Everything I talk about tonight, I do personally. And I've been doing it for a long time. It helps. Consider it.
That's why I'm here.
Okay, good. And I'm not saying I'm right. These are all really thought exercises. So look at what you're doing and see if there's a way to improve. Early and continuous delivery. A lot of teams that work in iterations, say you're doing a 3-week sprint cycle or a 4-week sprint cycle. Nothing gets delivered until 3 days, 4 days before the end of the sprint. Oh, hi, it's demo day, we're going to deliver something. Or worse yet, it's the last day of the sprint, hi, we're going to deliver something. That's not continuous. It's not even close to continuous. It's smaller increments than, hi, we're not going to do anything for months and then we'll deliver something. But it's not continuous. End of sprint delivery only is not continuous delivery. And at regular intervals, teams reflect on how to become more effective, tunes and adjusts. If this was a Scrum session, I would be standing up here saying the retrospective is the most important ceremony out of all the Scrum-based ceremonies. Looking back at what we've done, figuring out what was good, and we want to do more of it, what was bad, we want to do less of it, and making sure that we do something different the next time. I go into a lot of teams and I ask, okay, what did you do this sprint? How were you organized? How did you work? And they say to me, well, how'd you do it last sprint? Same. How'd you do it the last sprint? Oh, we did the same type of thing. How'd you do the sprint before that, the last type of sprint? You're failing. Right there, you're failing. You're not tuning and adjusting. You can tell I'm pretty hard-nosed on a lot of teams, right? So, this one we'll break for questions because we have a dichotomy. The things I'm talking about here, we have two different things, the engineering, we have what we're typically seeing in Agile, and yet it's conflicting with statements from the Agile Manifesto. So I picked a couple of random cartoons. I actually like this. You'll be able to read it if you grab the slide deck. It's deliberately small enough you can't read it, so you get the slide deck. Any questions at this point? We're good? Okay. Let's ask some questions so I can take a drink while you're talking.
Where can we get the slide deck?
You'll be posting it on the meetup site?
Yep. And the video as well.
Edited, I hope. Okay, so now let's get into some practical guidance. Key phrase that I hear all the time and then I see it ignored: test early and often. It's good advice. Except what's the definition of test? To take measure to check the quality, performance, or reliability before putting into widespread use of practice. There's a lot more in the general umbrella of testing than system tests, unit tests, the things that fall typically under TDD. I see testing as a lot more. Not just coding testing. Every type of feedback provides a check, right? If I have an idea and I talk to you about it, and you say, wow, it's a good idea, or that's a bad idea, or here's an alternative, you provide feedback to me, and that helps test my idea. Falls under that definition of test. So, you have user stories that are being put on the backlog. How are those user stories tested? How are they tested for completeness? How are they tested for quality? How are they tested for applicability? When something gets brought into the sprint, a lot of teams are now using the term definition of done so they know when the user story is delivered. What's just starting to emerge is a concept called the definition of ready. Having a written thing somewhere, often a wiki, that says, before a user story can be moved into the sprint, bang, 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 bang. If it doesn't meet the definition of ready, it's not there. You can test your user stories before you start working on them. Any teams do that? Testing is the primary enabler of fail fast. If I do something and I'm making assumptions, or 2 of us or 3 of us are sitting around making assumptions and we're not testing it, we're not validating it, we're going to do a lot of work before we realize there's a mistake. The more feedback we get, the more measures to check quality, et cetera, the faster we're going to fail on a bad idea. And I love this one. Failure is not only an option, it is a valuable step on optimizing success. If you don't fail at certain things along the way, you're not likely to be achieving the best results. I have some teams that, every sprint we deliver every single user story. We haven't missed a user story in 6 months. Oh, sounds great, right? And all of a sudden you look and they're only taking in enough user stories to do maybe 60% of the velocity they could realistically achieve. But they've cut their velocity so far down that they're wasting 40% of every sprint nominally because they won't take the risk of maybe 1 out of 10 sprints missing a user story. They become too conservative. So I like this one, facilitating failure. How do we make failure easier? First of all, failure is not a desired end state. We don't say, oh, we failed, and stop. Because then that's the bad type of failure. We don't want those. But it is all the elements that precede eventual success. So, a bunch of people sit around and throw out ideas. You don't stop at the first idea that's thrown out and say, hey, that's good. You throw out a couple of different ones, you discuss them, and you will determine that some of those ideas are, in fact, failures in the light of the one that's the best. So, just discussions create failures, and you don't invest any time past the discussion. You do an experiment that validates the superior alternative. How many times have you been writing an application and you're like, well, I could design it this way, or I could design it this way, or I could design it this way? Or even something smaller. I have a couple of classes, I could implement them this way, I could implement them that way. Do you take the time to do some experimentation? I'm not talking about, big studies, but some experimentation. Just try a little bit of this, try a little bit of this, try a little bit of this, make some comparative measures, and then choose the one that's best and discard the other two as failures. It's actually a good thing to do. And of course, you don't want to get into analysis paralysis and try everything under the sun. Any work that provides a pathway for the future, but is not itself included in the future, are the things that I'm talking about. We want to embrace them. We want to be able to try as many things as we can. We want to bounce ideas. We want to get feedback. But we don't want to waste money or time at the same time. So we've got to keep the cost of them low. Okay, so that's going to be sort of our goal. So how many people have heard the acronym OODA? OODA or OODA, depending on which coast of the US you live on. Nobody. Pity.
The OODA loop, you mean?
Yeah, OODA loop.
Yeah, I know what that is, yeah.
Okay. That change anybody else? I'm going to run through it then.
Okay, fine.
First O, observe. This is the simple definition. Take in all the information. Orient. Process the information in a context. So I've got all these inputs coming at me. So in software, I've got this requirement. I know we have this technology. I've got this time frame. I know we have this skill set. I've got a bunch of information that I can observe. Now I'm going to step back, orient. I'm going to try to process this all. And part of the processing is you'll come up with alternatives. I could do this, or I could do this, or I could do this. Next step, make a friggin' decision. Choose a course of action from the candidates that you involved in the orient, which means a lot of your that initial testing that I was talking about of ideas and discussions happens in the orientation phase. And then once you make a decision, act on it. Sounds pretty simple. We look a little bit deeper. First of all, it's not new. It was created by Colonel John Boyd, circa 1970 is the first time he published anything on it. And what he was referring to was the battle between MiGs and US warplanes during the Korean War. The US warplanes were bigger, faster, more heavily armed, better defensive, and were incredibly complex to fly. The MiGs were weaker, slower, but they didn't have that much, so it was easy for the pilots to do it. So the pilots could go back around and get through their OODA loop very quickly. Look around. I don't have that many options. I'm going to do this. The American pilots go around, oh, and I got all these gauges, I got all these. Remember, there was no computer's assistance back then, right? It was all manual. I could do this, I could do this. By the time they decided to act, the MiG had gone and gotten a gun on him. He made these recommendations to Congress. They changed, and out of this, the F-16 was born. And American fighter planes became virtually unbeatable, even though they were, by many metrics, inferior to previous aircraft. But you could do the OODA loop faster. It's not simple. I just gave you 4 simple little bullet points. Getting good at doing all 4 of those phases takes practice. Fastest is not the best. Okay? Just, hey, we're going at this speed. Would there be an improvement from going faster? You'll reach a point where going faster, you're going to start missing things. You don't have enough time to do what you have to do in each of the 4 phases. I mean, the original quote from Colonel Boyd was get inside the enemy's OODA loop. So whatever your enemy is, the constraints that cause you problems, you want your cycle time faster than them so you can react to them rather than having to get blindsided. This is the closest thing to an official diagram. This is a cleaned up version of a sketch that he did. As you can see, I mean, we have the 4 things at the top that I did with just one line. But you can see there's a lot of things coming into here. There's a lot of cross things that happen in your orientation. Then you're making your decision. Do it and come back around. And what do we have? Feedback, feedback, feedback. Feedback is testing. There's some great stuff to read on that. Just do a search. Okay. Anti-patterns, slowing your loop time. Anything that slows down your loop time without providing value. If you find you're missing things, yeah, then you have to spend more time in it. You're not doing that phase right. But saying, oh, we're going to slow down. It's an anti-pattern. Inhibiting the ability to perform any of those elements. So if there's something blocking you from getting critical information, that's a problem. I mean, if you don't have the information to come in, how can you analyze it? Yeah. Any questions at this point? Okay. Now we'll get a little more technical. Now I'm actually talking about code. Finally. One of the things I love doing when developing code is establishing isolation boundaries during development. If I write code and I check it in on main and nothing calls that code, what's the odds of it breaking something? It's not 0, by the way, but it's tiny. You could have funny things of, you made the assembly a little bit bigger, which causes an issue with dynamic page loading, and you know, yeah, there's some really small fringe steps, so it's not a 0, even that's not a 0 risk. Going in and editing a comment, you can make a typo, right? Accidentally delete a line of code. But it's not significant. So if we are writing code that's not invoked, we can check that in quite quickly, right? Easiest way to do that, implement from the bottom up. I just finished the slide deck this morning, so I'm not sure the order of some of the animations by heart yet. How many people get a requirement, oh, we have to add a new function to some screen, and the first thing they do is put a button on the screen to do it, and then start filling in the logic behind it. Come on, admit it, how many? As soon as you put that button on the screen without full tested functionality behind it, you've got a broken system. On the other hand, if you say, this is going to require additions to the database. Notice I didn't say changes, additions. You can add new things to the database. It's going to require some new stored procs. You can write tests against those. It's going to require a data access layer. You can test your data access layer. It's going to require some business logic. You can test your business logic. You can bring it all the way up that you have a full piece of code developed and tested before it has contact with any of the other code. Then your last step, hook it together. Develop from the bottom up. Keep your code isolated. Test your implementation as much as practical. I just finished doing a session. I did it at the Scrum-Masters Guild over Tampa Bay Agile last month, and I did it down at Code Camp 2 weeks ago on effective testing. Metrics like we have to get 100% testing are false. I don't want to get too distracted on that. But you want to test your implementation as much as possible. Build your little piece, do some technical unit tests against it. Put 2 pieces together, do some integration tests on that. Keep putting it together, putting it together, putting it together, so that when you hook it up, it's not, oh, I've hooked it up, now let's start testing. It's, hey, I've got this tested, somewhat proven thing that I'm integrating in. And so you keep doing that. Bing, 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 bing. Then finally, you connect it. Another technique that's very good, so that's the order you write code in. And I've worked with some teams that when they do that, plus what I'm about to talk about, they have virtually eliminated branching. They're safely checking in right on me. So the second thing is something called feature flags. Feature flags are really cool in concept, but not so easy to get right. There's a lot of good documentation. There's some libraries now out from Microsoft with .NET to even give you some implementations. But the idea is that for any point of contact between the user and the system, you have a flag that you can turn on and off. So you initially write some code, you've integrated it in, but you wrap it in a feature flag and its default is off. This means that once you do a little bit of testing, you can deploy it, because even though it's integrated, everyone sees the flag is off. It doesn't impact them. Then you turn on the flag for the developer group. Hey, everybody, let's speed on this for a little bit. Looks good. You turn it on for a bigger group. You turn it on to a UAT group. You turn it on to your early adopter customers. And all you're doing is going into some sort of database or registry or something, some XML file, JSON file, and just saying, hey, add this group, and eventually you say, add everyone. What's nice about this is it also gives you the ability, I think I'm jumping ahead on my animations, it also gives you the ability to say, oh, that's broke, turn it off, without having to redeploy. They can be per user, per role, per environment. It's a cross-cutting concern, which means just like logging or exception handling, you should have one consistent method that you apply across all your areas of your program. So you design your feature flag subsystem, same as you design a logging subsystem or anything else. You design it as a subsystem and plug it in. Don't start having tons of if-y statements all over the place. It gets unmanageable very quickly. How many people here use TFS or VSTS? How many people are using the online version, VSTS? Okay. That lives on feature flags. Every sprint, which is every 3 weeks, at a minimum, they deploy a new version. To the general public, most of the feature flags are turned off. To the ALM Rangers and some of the ALM MVPs, they get turned on once they get smoke tested by some Microsoft people. Get good feedback there, they get turned on to certain people in beta programs. Then they get turned on to people who are in the early adopter program. Then they get turned on to people who are in the fast adopters, so-called ring 0. Then they get turned on to the general public. That can be about a 5 to 6 week cycle of it getting turned on bigger and bigger and bigger. They do something wrong, it gets turned off and the public never knows. But that code's been deployed, they don't have to redeploy, usually. There's been 2 bad deployments in the entire history of ESO, where they had to go, crap, and pull it back. But those were both detected before anyone in the public saw it. So it's not perfect. As I said, elimination reduces the need for rollback. Rollback is really hard. Rollback is really hard. Because if you're doing a deployment and the deployment itself fails, you can restore to the backup that was in place before you started your deployment, because you always back up before deployment, right? But as soon as you turn the system on and start accepting new live data, and it's going into it's going into a database with a different schema, you can't roll back to the old. Imagine what would happen if Amazon discovered a bug today and had to roll back to yesterday's set of data. Oh, sorry, we just lost every order in the last 2 days, including those which have been paid and those which haven't. Do that once, maybe twice, and they'd be gone. They might survive one, they're big enough. Rollback is hard. Strive towards roll forward. Have contingency plans in place saying, hey, we're rolling out this change. If it goes bad, what thing do we add to it to fix potential problems? Which is basically means disable it, which can mean turn off a feature flag. And at the database level, I mean, I've extracted this information from a week-long series that I go called Code Excursion, so getting it into a time box is fun. Little things like, sometimes you use stored proxy access to your databases, that has pros and cons. A lot of times you do direct table access, but you can get tremendous value by using views instead of direct tables. Because a lot of times you can keep your underlying schema the same for a while, change the view. It may not be optimal, you may be doing an extra join behind the view until you prove it, and then you can change the tables underneath and transparently do it, so you're not losing data. It's about a 2-hour talk on that. Once you reduce the need for rollbacks, and once you make sure your code is tested and you can turn it off, you reduce your branches and merges. And I don't care what source control system you use, branching may become easy, merging is always hard. Especially when it's big changes. There's no easy answers to merge. Anyone tries to tell you, oh yeah, use X. I'm deliberately not mentioning a certain thing. But use X and merging will be easy. Yeah, run. How many people here have heard of S.O.L.I.D, the acronym? Good, but I'm not seeing some hands. So once again, it's a 5-letter acronym. It was created by Robert Martin, Uncle Bob. Him and I love to have sparring matches. If you ever see a conversation that him and I are involved in technology, it's fun. We have slightly different viewpoints. We both respect each other, but we love to devil's advocate, if nothing else. So the first letter, S, is for the single responsibility principle. And there's the definition of a class should have one and only one reason to change, meaning a class should only have one job. My simple definition of that, and this is not an object-oriented design class, I'm going to go through these pretty quickly. We can always have follow-up and questions. I'm here as long as there's someone to talk to. Simple test for, are you following SRP? Can you describe what the class does without using the word and? This class accesses the data and presents it up. Can you document what the class does without using the word and? It's a good test. I mean, it's not perfect. But what's this going to mean? It means you're going to have a lot more classes, a lot smaller classes. Smaller means simpler. There's a whole thing on complexity and complexity testing. I'm drawing a blank right now on the guy who's written it. Roger Sessions has written some amazing stuff on complexity and complexity testing. It's not linear. It's not linear. As code size grows, the issues with that code go up almost exponentially. But when you have smaller pieces of code and connect them together, it goes up nearly linear. So your total effort, instead of having one big class, of having, I'm going to pick 5 smaller classes that talk to each other, you're most likely going to be cheaper, better, faster in your development and your maintenance. Open-close principle. I love being a hardliner on this because you really can't. Objects or entities should be open for extension but closed for modification. This means that once you have a potential consumer of your code, and so right, you may have a product release that's 3 months out, but you may have other developers or other development groups that are using your code. You've released it. There are other people that you don't know using it. That means any public class, any public method, any protected method where they can override. You put that into the source control, somebody links against you, you've published. Open close principle says, once you write it, you can't change it. Oh, this method took 2 parameters. We need a third. Figure out what to do with that and add a new method with the 3 parameters. You could also go with a default parameter and sort of fake it, but again, I'm not getting into details. Beautiful place to do this that's available in .NET is a lot of times extension methods are a great way to go. How many people here regularly write extension methods? 4 or 5. How many people here regularly use link? A little bit more. I've done a lot of audiences where link, extension methods. Link is nothing but extension methods. So you're using them, write them too. Because this way you haven't modified the class. You've extended the class. Extension methods extended the class. Little coincidence there? Liskov substitution principle. This is what I love. Have you ever read the, he's smiling. Have you ever read the formal definition?
Yeah, the mathematical one.
Let Q sub x be a property provable on objects of x of type T. Yeah, no. If you write something that takes a base class as a parameter, it must accept any derived class and function properly. So if we had a biology system and I wrote a class that has a method that takes an animal, I better be able to pass it a dog, a parakeet, a bacteria, anything, and it better work. Otherwise it doesn't take animal. But I just was like, huh? Interface segregation. A lot of people say, oh, I use interfaces. I don't have references to my customer object all through my code. I have iCustomer, and I use that through my whole code. That's not what this is talking about. Interface segregation says, that's the formal one. Interface segregation says, having a lot of little interfaces allows people to be concerned with just the aspect they're using, and if you have to substitute in a different class for a specific use case, it's so much easier because you only have to implement that little part. So instead of iCustomer, you may have iCustomer sales history, iCustomer billing, iCustomer. 5 or 6, 7 interfaces that break up what a customer is. So now your accounting package just worries about customer billing. Your RMA team worries about customer orders. Does that make sense? See where segregation, breaking up into lots of small things, is different than just having an interface. Dependency inversion principle. I love this one because so many people read that as dependency injection. The two are different. Dependency injection is a specific technique, typically a pair of techniques, property injection and constructor injection being the most common, that are used to implement a dependency inversion. Simple answer of dependency inversion is for classes that you are in your domain, so within your business application, within your libraries. I'm not talking about things like string that's down in the framework or date time. Don't use new. It's really that simple. Don't have a bunch of code within the middle of it. Hey, I need a new order. Because if you want something other than an order, you have to go change every place in the code where it's new order. Dependency inversion says, do it the other way around. In the middle of your code, say, hey, you, give me what represents an order and use the appropriate segregated interface. You could use heavy DI containers, Castle Windsor, there's so many of them out there, or a simple factory pattern. Simplest factory pattern in the world, and unbelievably effective because it's so easy to slam through an existing code base. Add a static method to the class called create that takes the same parameters as the constructor and make the constructor private. Do that to a class, you'll get compile errors. Delete the word new, put .create in there. You can spin through a 1,000,000-line code base in a couple of hours to a couple of days. Boom! You've implemented dependency inversion. Now you can go inside that and say, oh, instead of using this factory, I want to make it more sophisticated. I'm going to use tools like resharpen and say, oh, I'm going to take this out of this class, put it in its own class, so I can move it over to being a container. But just that first, implement a create, doesn't have to be called create, I just like the word create. Implement a static method to create it in the class, privatize the constructor, flip your code. You've done the hard part of getting on the road. Official definition. DRY. Anyone not heard of DRY? I'm going to reverse the question. Anyone not heard of the DRY principle? I just violated it. I repeated myself. Sorry. Attempts at puns. I can't help it. DRY principle states that small pieces of knowledge may only occur once in the entire system. Every piece of knowledge has a single, unambiguous, authoritative representation. If you're using Visual Studio 2015, and I believe it's only an Enterprise Edition, there's a feature called Code Clones. It's a wonderful tool. You point it at an assembly, or even your whole solution. You say, find code clones. And it looks for duplicates. Its granularity is 10 lines of code that are semantically the same, not necessarily lexically the same. So I could have for x equals if y, for with an if that has a certain pattern. Okay, think about, if you're geeky enough, think about the IL that would be behind it once you stripped away all the variable names. Now over here I have something else that has very similar or identical IL. The variable names might be different, but the functionality is the same. It flags it and goes through your code and says, you got duplicates, you got duplicates, you got duplicates, you got duplicates. If you want to go smaller than 10 lines, you highlight a piece of code, 2 or 3 lines, and say find duplicates. How many chases do we check if customer equals no? If customer equals no, boom! Even if the variable is not called customer. Because it's checking for, are we checking a local variable of type customer to be equal to no? Amazing for reducing duplication. And that's why commercially when I'm working, I do this type of training in conjunction with working with the teams, working in their code base and actually applying this stuff. So this didn't come out as well as I wanted, but it's basically software project broken down into components, components broken down, down, and then aggregated back up to come around, the DRY principle. So those are 3 major things. Keep isolation boundaries, follow solid, and follow dry. Do those 3 things in your software design, and I guarantee you things will change, and they will change for the better. Can't guarantee how much, but I can guarantee it will be a noticeable change. And one of the things I mentioned before at the beginning was you go through the whole sprint and you deliver at the end of the sprint. What's our intra-iteration workflow? What's our workflow within the iteration? And this is one where I like to get Scrum Masters and product owners and other external stakeholders involved to explain why we're doing what we're doing as developers when we adopt these things. Because if the people outside the team don't understand why and what the benefit is to the development team is not going to be given the ability to self-organize. You got to convince the business is there to make money. You got to convince the business that when you self-organize as a team, you're providing a better value to the company. Yeah, you're also making your own lives easier, which is great. You know, you can go home at night and say, hey, today's day at work wasn't so bad, instead of it. First thing, collaborate, collaborate, collaborate. You want to know how to drive me nuts? Hire me to do a contract, say that I have to be on site, and then have it so I'm sitting in a cubicle not interacting with anybody? What the heck am I doing in Fargo, North Dakota for a month and I haven't talked to anybody? Why am I here? Well, you're doing a lot of work on the computer. I could be doing that in St. Petersburg. It's nicer than Fargo. Except in June. But Fargo's kind of pretty in June. Collaborate, collaborate, collaborate. One type of collaboration is daily stand-up, daily scrum, whatever meeting you call it. How many people here that are on teams have some type of daily meeting? For how many of you has it denigrated down into a status meeting? Shortest scrum meeting, shortest daily meeting in the world. Everybody walks in and you ask one question. Are we confident that we will meet our deliverables for the sprint? Roman vote. Yes? Yeah, maybe. No. Ideally, you get all thumbs up and say, okay, great, we're on track, and you leave. Meeting's over. Somebody goes, I don't know. Focus on what do we have to do to get that back up to here. Somebody goes like this, stop and go, how the heck did we get to here without first getting a here yesterday? Because you got a big problem. Shortest in the world. Usually too short. Second shortest, especially when people are using TFS. The key things at this meeting is, what did you do? What did you finish yesterday, and what do you plan on finishing today? Now, what did you work on yesterday? What did you finish yesterday? What are you going to finish today? Why do you think that's the focus? Anyone?
It's delivery.
It's delivered. So you're right. Work in progress has no value until it's delivered. It's potential value. But going back to the collaborate, 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 I may be looking at the workflow going on and saying, hey, I have to work on this piece of code, but I can't do it until that is done. So by a person saying this is done, it enables me to say, oh, I have to take a look at my part. Person says, I'm working on this today. The team knows the code base well. We may have a major, gotcha, I'm going to be working on the same piece of code and I'm doing a major refactoring. We should probably change our plans for the day so that when I do this major refactoring, that's not going to merge. I mean, the ultimate non-mergeable. Do you ever do a resharper organized code? So it puts all the publics at the top of, yeah, you'll never merge that. You want to make sure nobody else is doing changes when you do that, right? That's what, this is what I'm doing today, what I'm working on to finish today. Also, cross-training. I may know that there's some part of Angular I don't really have a good feel. I'm not a front-end guy much. I can fake it, but that's not my expertise. You say you're going to do something in Angular. I'm like, oh man, I've been struggling with that. Hey, listen, my work was pretty light. Mind if I pair up with you today? So I can come sit in while you do that, because I'd really like to learn. The purpose of those two questions is, yes, the value part, but also the collaboration part. Helping the team coordinate. The fact that I'm in the middle of working on something really doesn't tell anybody anything. Now here's the other fun one. I jumped at automation. Who attends your daily meeting? All the developers, right? Scrum-Master or Agile coach, almost certainly. Some people, the product owner. Well, general rule of thumb, welcome them as an observer, but not if they're going to disrupt a meeting, and not if it's going to inhibit developers from talking freely. But in a good, healthy team, product owner there is good. But what's not there, ever, in any situation I've seen? The business people. But the manifesto says business people and developers must work together daily. It doesn't say that the developers all have to work together daily, interestingly enough. But this part is left out of this. Having this does not give you this. That's another form of collaboration. Delivering throughout the workflow. Full sprint work occurs risk. Okay? I've seen teams, oh man, have I seen teams. They pull in one user story for the sprint because it's big. What are the possible outcomes of that sprint? Success, hey, they managed to do it. Or abject failure, they delivered 0%. You don't want one big user story. Generally speaking, you want 10 or more, because then you can get a 90 and 80. You know, if you have 10, you can get a 90 and 80 and 70. You can miss perfection and still get a passing grade. But what I've also seen a lot of times is, I'm going to make it simple. Team of 3 developers has 3 user stories. They say, I'm going to do A, you're going to do B, you're going to do C. And each one's going to take 90% of the sprint. And we'll be good. We'll finish it right before the demo day, and we'll be good. And then something that doesn't happen down here, but I'm from New York. We relocated down here a year ago. I'm from New York. You get a snow day or 2. And every single user story fails to meet because you lost a day in the middle. Well, they call a corporate meeting. I mean, there's many things that can block you. If a work run, I mean, that's from start to delivery of a piece of value, is going to take your full sprint, you have a lot of risk because anything goes wrong, you're going to miss it. Paced delivery allows others to provide faster feedback. So take those same 3 developers, same 3 user stories. Hey, let's all work together on user story, and a 3-week sprint just to make my life easy. We're all going to work together on user story 1. First week, user story 1's delivered. Second week, we're all going to work on user story 2. And the second week, user story 2 is delivered. I hate that light. That's what I'm saying over here. Final week, user story 3. What does that do? If you still have, and most teams do to some degree, have an external QA department or user acceptance testing or whatever, they can start looking at the results of user story 1 at the end of the first week. They're not waiting for the last 2 or 3 days to look at the code. Delivering value throughout the sprint, end of the sprint is better than months at a time, but end of the sprint is really not ideal. It's high risk, and it does not promote good flow. Agile process 4. Agile process promotes sustainable development. If you're delivering at the end, what are your business people doing? What are they doing within the context of that sprint? Nothing. Near the end. What are the QA people doing near the beginning? Nothing. You have these idle periods and spikes, idle periods and spikes, idle periods and spikes. It's a stretch to call that sustainable. Because the spikes will overrun. People get pulled off on oh, you're idle, let's come work on this project, and you don't see them for a month. So what are some techniques that teams can do? First one, pair programming. Anybody have any experience with pair programming? I think it's extremely powerful. Unfortunately, up to 90% of the cases I've seen devolve into what's called the worker-observer pattern. You have 2 people sitting at a desk with 2 monitors, 2 keyboards, a beautiful team setup. One person sits there and goes, yeah, well, the other person's working. You're wasting a person. That's not what pair programming was intended to be. It's easy for it to fall into that. Best way I have found to avoid it, I love watching this, especially in certain environments, is called ping pong TDD. So, I have some issues with pure TDD, straight out of textbook, but ping pong TDD, you've got a requirement in here. So I've got my user story, we know this code has to do something. I'm going to write the tiniest bit of code I can and a test that from that set that fails. I'm going to pass, you now have control. You have to write just enough code to make the test I wrote pass, and then write another test that fails. I have to now write enough code to make your test pass without breaking the one I wrote previously, and write another test. In really competitive teams, I've seen this cycle time can be between 3 and 7 minutes. Now I'm going to contradict myself, apparently. What happens is the person who's on the keyboard for those 3 to 6 minutes can go at full burst speed, total sprint, run anaerobic, 25-yard dash speed, because the other person's cycling down to near an idle. They're still thinking about the code, they're still watching, they're thinking about what test are they going to throw in next, how are they going to be fixing, they're watching him write, they're like, how am I going to be fixing that? But they're somewhat idle. Then it kicks. And you have these bursts that are very short with rest periods behind them. Similar if you ever do weights at the gym, I don't, but doing multiple sets, you work hard, rest, work hard, rest. TDD ping pong is amazing. There's another technique called mobbing. Mobbing is the team, or if it's a big team, it could be a part of the team. If you're in the 5-person range, it's usually the entire team. Working together to achieve one deliverable. Like, okay, here's something. This is going to be hard. We're going to sit together, around a conference table, bang, knock this out. Taking everybody's input. You have to do this, do that, do this. The other is what's called swarming. And mobbing and swarming are different. It's the team focusing on one type of work. So during a sprint, you may have these minor bugs that have been identified. They're not blocking anything. They really need to be cleaned up. There may be some code that hasn't been tested as well, that somebody should just play around with. Declare a day in the middle of the sprint. Hey, it's bug hunt day. And the entire team is going to swarm and do one type of work. So see here, swarming is a type of work. Mobbing is focused on a deliverable. If you have big things that can't be broken up, mobbing is a great way to shorten the time frame, the clock time of it. Prevent it running the full sprint. One of my favorite topics. One of the ones that I'm often afraid when my car's outside that they're going to let the air out of my tires. The changing role of QA. There are some people who say, with Agile, we're doing testing as part, we're doing test-driven development, you don't need QA. Wrong. Very, very wrong. First of all, if developers write unit tests, the only thing you can test in a unit test is that the code's doing what you think it should be doing. If I misread a user story and write the wrong code and test that the code behaves wrongly, my unit test is going to pass. It's not right. So you want people outside the developer who wrote the code or was involved in the writing of the code if you're pairing, somebody else to be doing a higher level of test. But when it comes to QA, there may be one here. People who have been around long enough, remember there used to be 2 different quality departments in organizations, especially engineering organizations. The first was quality control, the QC department. The other was the QA department. And the two of them often hated each other. QC was the one who did the testing, the mechanical testing, puts the little shirt in, inspected by number 3, the seams are good on the shirt. That was quality control. Quality assurance was very different. Quality assurance was stepping back, looking at the overall process environment, raw materials, human work, and saying, is this way we're testing and the way we're working a good set of processes, methodologies, approaches, tests, data collection, data retention, data analytics, to maximize our quality while keeping costs under control? That was the role of QA. Back 40 years ago, and yes, I've unfortunately been doing it that long, running tests was QC, not QA. And quality means much more than passing functional tests. So, development team puts together an application, say in big ASP.NET app. They write it, pass all the functional tests, they say, okay, now let's load test it at scale and see what we have to do to deploy this to production. And so they start hitting it with load tests and simulate loads, and they come up with, okay, 25 servers will handle the load. Management goes out, buys the 25 servers, stands them up in the data center. Somebody else comes in, looks at the code and goes, you know, if you design this a little bit differently, it would have been more efficient, and let's rerun the load. Oh, you could have gotten away with 6 servers instead of 25. You bought 19 extra servers. You've provisioned your data center. You've got the power, all the ancillary stuff. You've just spent $1 million on hardware you don't need. Would you say that's a quality problem? Yeah. Is running functional tests, that type of QA, going to catch that? No. There needs to be a distinct group focused on the quality assessment and remediation, and the team needs serious technical skills. I was out doing a contract. I was in Irvine, California. If you've ever been out to Southern California, there's a highway called the 405. Puts together traffic like you've never seen here anywhere in Florida. But it has these big, big interchanges, like you're starting to see here in Florida. Flying buttresses going around, 17 ways on, 17 ways off. And we were looking out of the training room at one of them. And people were talking to a bunch of people who were, hi, we do QA. Well, how much do you know about software? Nothing. We read specs, we write tests, we run tests. I'm like, okay, look at that big construction out there. If I told you the QA person on that, who assured me it was good, had no knowledge of steel, no knowledge of concrete, no knowledge of wind shear, no knowledge of earthquake tolerance. I'm in Florida, so I think hurricanes. Would you want to be on that bridge? Everyone, no. To assure the quality of that bridge, you need all those technical skills. To assure the quality of software, people need those technical skills. Step back and look at QA. There is a need for testing. There is a definite need for writing the formal test, running the test. If any of you happen to see my presentation on comprehensive testing, I'm a big believer in drive down the cost of automation so that any test that is definable, do this, check this, do this, check this, do this, check this, is automated, and that all your exploratory tests where people can really see things and using their brains is what's done by humans. I did companies swore that their testing was great, nothing to get through their testing, they had great testing. I had them set me up a sandboxed environment. This is a fun story. I said, here, give me your source code, we'll set up mock environments, we'll run the tests through them, and we'll get it to the end, and you tell me if you deploy to production. So I went in, I mucked with their code, and they found a couple of things. But there was one thing I did that made it all the way through their testing. And it was a customer application. Customers had a credit limit. And some of the tests involved changing the credit limit. Some of the tests involved, trying to do purchases exceeding the credit limit. Well, I put a little hack in their code that if you change the person's credit limit, their gender would change. If they were male, they would become female. If they were female, they would become male. And their avatar would change to a picture of Pikachu from Pokemon. My youngest grandson was really into Pokemon at the time, so that was a picture I just picked. It made it through all of their testing. I went back and talked to some of the manual testers. Said, did you notice? No, none of them noticed the gender change, because that was just one little letter on a part of the screen no one was looking at. Did you notice the picture? Oh yeah, we thought it was strange, but there was nothing in our test plan to fail about it, so we let it go. If you take people and tell them to do something, they're going to do what you have to expect they'll do what you tell them to do. On the other hand, if you help people play with this and look for any anomalies, look for any things you think are off, exploratory testing, all that stuff would have been caught. So the changing role of QA is let the computer do the repetitive work. Cut down the cost of automation. Get QA so that you're really looking at things across the board. The people who are testers still have a major job. Some of the senior people who've been around in that area for a while can start giving you things to start looking for. Do not become metric focused. Hi, we need to reach 85% code coverage. Well, I can do that to your code in a day with totally meaningless testing. I'll probably get you to about 93% is where I can usually hit in one day. I don't care how big your code base is. I'll get you 93% code coverage. Doesn't mean a thing. And bottom line is keep it simple. We're actually getting near the end. What time is it?
8:12.
8:12. Okay, I don't know. Keep it simple. Now, that's often the KISS principle is often attributed to, well, this quote, make things as simple as possible but no simpler, is a great quote, because you can't oversimplify things and start missing things. It's often attributed to Einstein. If you get the deck and want to look, it's almost surely not an actual quote of him. It's a sentiment he expressed multiple times, but he never used those words as far as anyone can determine. Do small steps on a long journey. This is why we have iterations, this is why we have the retrospectives. Don't make the mistake, not even talking about this, but anything you're doing in your process, don't say, oh, starting March 1st, but it's already March 2nd. Starting April 1st, starting Q2, we have to do things big, different. Major disruptive change. No, that's high risk. If it doesn't go well, you're screwed. Lots of small steps on a long journey. And the journey never really ends. I've been doing this professionally since 1976. I am still learning. I try to invest about 15 hours a week keeping up with changes and improving and doing things to improve. You're not going to get to the end of the journey. You're not going to get to a point where, hi, we've developed the perfect software with the perfect But you can take small steps. You can go into work tomorrow and do something a little bit different. See if it works out a little bit better. If it doesn't, if it's small enough, no harm. If it does, you can build on it. I love this one. My head hurts. It's because there's too much in it. You learn one more thing, it'll explode. So that's basically the end. Any questions? Feedback?
I have one question about the business being involved in the daily meetings.
I didn't say that. The business being involved with the developers daily, not in the context of the daily meeting, if I wasn't clear.
I find often it's a challenge for them to want to be there. That's one of our challenges.
Okay. Thought for you to do. Look at it from their point and find out what is the value they are getting from attending the meeting. If you cannot provide them a value with it, think of a different approach. And you and I can talk afterwards about some specific things. But that's the thing. People are selfish, right? If people see they're getting a value from something, they're more likely to do it. Like one of the things I love doing, I'll just go into this real quick, it's from my other talk. But you familiar with gherkin syntax and cucumber?
Oh, yeah.
Getting business people to write their tests or their acceptance criteria as gherkin can be a challenge.
Sure.
Simple solution. I've seen it work great so many times. However they give it to you, just accept it. Internally write it in gherkin and send it back to them for review. You'll get some early adopters quite quick who realize, oh, they're taking what we have, rewriting is this, and that's what they're gonna, and they'll start writing closer to gherkin. They're not gonna write formal gherkin, they'll write closer. And they'll see that, hey, we get it back for review quicker when we come closer to the format they want. They want quick turnaround on their tests. They don't care how they phrase it, that's not a value to them. But if they start seeing they're getting faster turnaround, like, oh, we gave you a new test, and that night's build had that test running automated. Wow, that's value to us. How do we do more of that? Put it in their shoes, and that's for everybody. Put things in their shoes, and if you can show that you're delivering a value proposition to them, people will usually adopt. If you can't, then double think why it's being done that way. Why is it a one-sided value proposition? Okay, now the reason you all came, the lottery.
Well, I had a question. You guys said something early on that you yell at people and tell them they're wrong. Obviously, in a business sense, especially being paid as a contractor, I'm sure, coming into an environment, how do you approach that differently? Good ideas on giving them the incentive and giving them the value, showing them the value. But
It can be challenging. When I'm dealing with newer clients that don't know me that well, I have to be much more laid back than my natural state. But it goes back to what I was just saying here. Show them the value. I've done things where I'll invest some of my time they say, oh, it will take too long to get tests running. Case in point, I did this last week up in Atlanta. Company had an ASP.NET app. They had logging on every request response. They were starting to do browser-based testing that was automated. They wanted to start automating browser-based testing. Coded UI with Selenium. And they were like, how far are we going to get along this? I said, well, you can do browser-less testing pretty quick. And they're like, how? I said, run your manual tests and just keep track of what parts of your existing log are there. Then we'll extract that data from your log file, put it in a different data file, And then we'll just use load testing to send and receive the responses. And they're like, what? That'll work? We spent about an hour on it, got a couple of them to work. They're like, wow. By the end of the day, we had 200 automated tests at the request response level instead of coded UI, where they were hoping to get 2 or 3 tests a day working. Show them. Find out what they really want as value. Show that to them. They'll be on board. Yes?
For the feature flags, are there like frameworks for that already?
There's some starting to come out. Microsoft has just released one that's up on NuGet. Oh, I'll be remiss if I don't do this real fast. How many people here use, does anyone here not use NuGet? What kind of development do you do? Okay.
So real-time tracking software.
Okay. And you is it any ASP.NET stuff? No web stuff? But put it this way, the newest .NET framework, .NET Core, which is where everything is going, the framework itself is a NuGet package. If you're using the latest stuff in Update 2 of Visual Studio 2012, you cannot develop a console application without using a NuGet package. NuGet packages have 2 potential issues. 1, you don't know who wrote them. Stick with reputable ones. The risk is really small, but there's been at least 2 confirmed cases I know of. Second, be really careful about licensing. Every NuGet package you download has a little license and the person clicks to accept it. That's part of the interactive ad. On Package Restore, it doesn't happen.
Yeah, I'm working on a project now. We have to get every single assembly approved by a law firm. Every one.
For NuGet, it's very simple. Set up an in-house repository. Don't use NuGet.org. Allow developers to still use NuGet.org unless you have regulatory issues. But your build machines, don't let your build machines get from NuGet.org. Allow them to only get from your in-house approved registry. I had one client end of last year. They almost got sued out of existence. They had included a GPL, General Public License, package into their product. It was termed to be included, not linked to, because they built an installer. Therefore, it was included. They were sued to release the contents of their proprietary business analytics software, including all their intellectual property. They settled for $2.5 million. This is because a developer downloaded a NuGet package. They're great. I love them. Put management around them. Yes?
Log4net has also had breaking changes in the past, and if you're using the NuGet package, I've been involved in 2 different corporations where production went down when the next time you did a build and there was a signature change of Log4net. So yeah, I totally say use.
Did somebody do an upgrade on Log4net? Because at a given version, it never changes.
You just use. I mean, most people that use NuGet use latest.
Yeah. No.
And so Log4net change.
Yeah, I mean, when you go in, I may lose some of you here, but in Visual Studio, you go and you see your installed NuGet packages and its updates available. There are people who go clickety, 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 clickety. No! For every one, depending upon scaling, for every one of them, put something in your backlog to, evaluate if package X should be upgraded from version 1.1 to 1.2. Schedule in your backlog. There's work to do before you click that upgrade link. And that's why by putting things in an in-house repository, you shut that off because they can click it. They'll take a dependency on their workspace. They'll be fine. They go to submit to the build. The build machine can't get to NuGet.org. It can only get to yourcorp.org. Your corp NuGet. And boom, it fails because it can't restore the package because it's not an approved package. It takes about an hour or less to set up. And Visual Studio with Update 2 and VSTS as of the next rollout, which will be in 2.5 weeks, we'll have package management right in VSTS. So you don't even have to go get a package server. Yes?
You mentioned before something I've seen, some supposedly Agile teams claim not to do architecture. How do you talk to your clients who are avoiding architecture or any?
I focus on the emerge because it really is part of refactoring. Okay, is that you want to improve the design. So you start looking at, hey, we have a code base. What design elements in here? What architectural elements in here? And architecture and design are 2 different things. What's coming out of this? Let's look at the packaging programs that have been delivered to production over the last 6 to 12 months, depending upon their cadence. Let's extract what the architecture is. Why was that chosen? What are the deviations from it? Instead of trying to define it and push it, pull it. And once again, giving them a starting point helps. But that's why I love the fact that the best things emerge, and you just start looking, and because you start finding inconsistencies. If you have 4 modules and you look at this one, it's designed in this shape, the second one's designed in that shape, third one's designed in this shape, fourth one's designed in this shape. You're going to have some maintenance issues because people who work on this, they'll be in this mindset, they'll work over this, but they'll stay in that mindset, and you'll devolve to bowl of spaghetti. So by pulling the stuff out and looking at what they are, and then say, and if you're doing this on a fast enough cycle time, you catch, it's not like you have this big module that's totally weird. It's like, it's starting to go weird. Because where is most of your design work done, if it's done somewhat effectively? During the sprint planning meeting, when a user story is broken down into tasks. Again, this isn't an agile thing, but if you want to break down the task to the most detailed level, and I recommend people consider it and then back off to the point where it's reasonable. Have you ever built a piece of furniture from IKEA?
Yeah.
Every panel in there? I'm saying you get the instruction booklet, right?
Yeah.
The booklet is the user story. Deliver a book
Yeah.
stand.
Right. Yeah.
Every single panel in there, insert tab, each of those are tasks. Look how granular they are. Write code is not a task. Add this column to this database. Add this index to this. Create this class with the following public methods using this pattern. Class. Boom. Those are tasks. In an ideal world, you should be able to take a task, find a competent developer who knows nothing about your system, but is competent with the tools and environment that you use, and say, hi, I know we just hired you this morning, but here are 3 tasks, please go do them. If I give you a piece of paper that says write code, I'm sure you can go write code. Are you going to write the code I'm expecting? Tests are very poorly defined most of the time.
So you suggest the sprint planning meeting being where that granularity is defined?
The sprint planning time frame. Okay? Depending upon the teams, and again, this is why I don't like one size fits all. There are no best practices. There's some worse ones, but there are no best practices in the time frame. Depending upon what type of work it is, what type of skill sets there are, what the team division is. Beforehand, having some pre-things, and then the planning meeting becomes, hey, I looked at this user story because it was assigned. I took on to look at it. These are the tasks I've come up with. This is why I've come up with the task. They don't have a comment. Oh, don't do that. Do this. Okay, change. And then they become official by the end of the sprint planning. Not necessarily everyone sits down and they get typed in. Then you want to be pragmatic, but you don't want to do it before, because I don't have the example. Think about the times where you have 2 pieces of functionality that are related, and you're going to try to story point them. The first one you do, whichever one it is, you've got to create databases, create a whole bunch of things, create a whole UI, whole bunch of stuff. The second one you do, whichever way you do it, is going to be add a button and add a stored proc. So one's going to be very low, one's going to be very high in terms of real work. How can you task out which one until they're in the sprint that you know you're going to execute? Because the priorities can change right up until the start of the sprint. So if somebody says, you look on the back lights, A, and B's farther down. So, okay, we'll step out A with all this extra stuff. B will be the easy one. Morning before sprint planning, product owner goes and flips it around and says, I'm pushing B into the sprint. Task A will not only be stepped out incorrectly, task B won't be stepped out at all. So you want to keep it right in that time frame, but I don't think it's necessary right in the room. That can get expensive. Anybody else? Hope you enjoyed it. Hope you learned something. My contact information is up there. It's in the deck. I also have cards here if anyone wants. Feel free to catch me on LinkedIn, email. But the only contact I don't give out is my cell phone.
All right. So thanks, David.